up ahead! Looks different!
Everybody stay alert!
Star Fox 64 was arguably one of the best games on the Nintendo 64 system. The brains behind the game was Shigeru Miyamoto, Mr. Video Game himself, and with his design philosophy and principle, pretty much anything he touches turns to gold. With all this firepower behind it, Star Fox rocketed to the top of review charts and in sales. Star Fox 64 was also known as Lylat Wars in the PAL region, and it essentially was this on-rails shooter, which allowed the player to go through multiple levels, flying a fictional spaceship guided by its animal pilots. The spaceship was known as an R-Wing, and had multiple capabilities in order to defend off enemies and maneuver about. The game is focused around one particular concept, called all-range mode. All-range mode persisted around the idea of using 3D space to move a vehicle, in this case an R-Wing, around in an arena with full 360-degree control of the vehicle. And this started the concept of the design for Nintendo 64's Star Fox 64. In 2003, Star Fox 64 was re-released for the iQue player in China. Before this happened, Nintendo decided to throw a patent its way in the United States. And the US Patent Office, thanks to Google Patents, has this patent freely available to look at. And of course, I was intrigued, so I've decided to start a series on decomposing the design of Star Fox 64. Hi everybody, I'm James from Zygal Studios, and today we're going to talk about the system-level overview of Star Fox 64.
I see him up ahead. Let's rock and roll!
Today's an exciting day for me making videos. This was one of the games of my childhood that I adored, and even my own father played this game many times with me and my brother. The game was unique. You could play it through once, and play it again and have a totally different experience. The point of the game was to reach it to the end. However, getting the highest score was probably more important once you got good. And you had to realize that there were multiple ways to get from beginning to end, and this allowed for a fun game. There was a quick and fast way to go through the game and cop out with the robot Andross at the end. Wasn't really the full extent of the game. Taking another route would engage you to, well, destroy Andross and defeat his brain, and then free James McCloud, Fox's father. But anyway, enough reminiscing. Let's talk about the system-level design. So Star Fox 64, as I said before, was shot to the top of review boards, and it was praised highly for its precise controls, multitude of game modes, the voice acting that was provided by your furry counterparts, and is considered to be one of the greatest video games ever made. So being able to decompose this design, thanks to the patent availability, is amazing. This design is very complex. In fact, in total, the patent explains 47 different figures and makes 19 unique claims that was accepted by the US Patent Office in terms of a video game. It even goes as far as making a system-level overview of the Nintendo 64, talking about all the different hardware that's available, and even breaking those down even further, talking about how data communicates between peripherals from the CPU to the RAM on the bus, and the entire Joy-Con circuit is broken down as well. But let's move over to the ROM, because this is where things get interesting. According to Figure 5 here, the program area is broken down into 4 sections. The first section has about 15 subsections, and hold a multitude of information. And then there's a whole section for a character code, whole section for the image data throughout the program, and then the sound memory area, which probably occupies most of that. For those of you who don't know, Star Fox 64 revolved around a pretty complex dialogue system for the N64. One of the greatest achievements in game history, in my opinion, is getting these dialogues to run in such a sequential, bug-free, and clear, intelligible manner. The 64, remember, did not have any distinct sound processing system. So all of this had to be done on the CPU and tasked accordingly, and since the N64's operating system used preemptive threads, all of this had to be done when it was needed. When the program was laid out in RAM, i.e. transferring ROM to RAM, using the DMA, there were about 10 different sections of memory. The display list, program, frame, Z buffer, image data, sound memory area made up that first part of it, and that was mainly what was in the ROM. Then we start to get to the parts of memory in RAM that were actually changed on the fly. Things like the control pad, working data memory, the fellow or your friend's memory area, and then you had the register and flag area. 21 different registers were used for a multitude of things, most of it talking about damage or life indication and point tallying. There were also flags utilized in hardware as well, and of course there's the typical all-range mode flag and then typical game over flag. On a high level, this is how the courses were structured. When the player enters course 1 and completes it, they only have one option, which is course 2. In the middle of course 2, there becomes a fork in the road, where the player can actually go one way or another by decision making in the game, deciding where the player will go at the end of level completion by completing the boss. In this case, this offers the game way more playability. As we can see from this diagram, there are 4 different ways to get from course 1 to course 5 and complete the game. This means there's a decision point in each level, and based on these conditions, a player will either advance to one course or another. This allowed for playability through the game, to be able to go in each world and receive a high score. Here's where all-range mode comes into play. A typical start of the level starts in an on-rails type of situation, which is pretty much what a lot of 2D games were like before this, or even Star Fox before this as well. On the Super Nintendo, you were kind of stuck to an on-rails type situation where you were basically moving in a straight line and enemies would come straight forward at you. This is what's called a one-direction scroll mode, according to Shigeru Miyamoto. Each of these levels would have different sights, and in this case there would be different enemies and obstacles you had to avoid in order to get to the end phase. And then eventually, once a specific displacement unit was reached and the player was still alive, you would then go through what's called a mode shift. And this mode shift would change one-directional scroll mode into all-range mode, which was essentially allowing you to move freely within a confined arena against a boss. So instead of the on-rails gameplay you were used to, you were able to have full range of the aircraft. Something I found particularly interesting was phrase generation. Phrase generation was based off of a few key pieces. In every level, there were different phrases in a sequence, and sequentially in memory, that would be pulled from the audio data and sent to the audio buffer. These conditions were pulled as the player moved through the sights or reached certain conditions. For example, in this case, phrase 1 from Fellow 1 says, "Get over with the brake, see down button." In this case, Peppy says, "Use the brake." And in this case, when you're in Site A, the first priority is learning the controls. So these phrases were not only equipped with conditions that would trip them, but priorities. So if something more important was happening at the same time, and something needed to be generated, like let's say somebody was being chased, a higher priority task would take over. The entire flowchart from a systems level is broken down as follows. This game process is quite complicated, as most games are from this time, but it's broken down so clearly that even a person who has no background in engineering can see this from a system level and understand what's going on. We've already been through the course selection and some of the game's start process, so let's assume we're in the middle of a game. The first thing the game does is check to see if there's a mode shift available, meaning that the actor, in this case the player, has reached the final sight's edge inside of the map. If this is the case, it will then immediately shift modes first before doing anything else. The second thing it does is processes controller input and then gets filtered on the way in, according to Figure 18. We'll talk a little bit more about how that's done in a little bit. After the controller process is finished, the mode shift in the controller process happened first within the main game foreground-background design, primarily because these are the two most important things revolved around in the game. We need to make sure that we're in the correct mode so that we can operate whether a 3D space or an on-rails space of what we can do. The second most important thing is the controls. The player needs inputs in order to determine where they need to go. So the control scheme depends on the mode shift. That is why it's second. The communication with Fellow is the third piece of this puzzle. Your teammates will talk to you based on things that are happening in the game. And based on the mode you're in and the controller processes you're doing, these communications can change, and the priority system allows for multiple different audio events to be queued up at the same time. So the communication with Fellow needs to happen next. The supply from headquarter block essentially handles things coming in from Rob64 from Great Fox. Remember when you were able to call in from a message from Rob64 and he would drop you off supplies? This is exactly what that means. Now with all the foreground data present from the players and the situation you're in, we can now manipulate models in the graphics hardware through the RCP and send it out to the frame buffer. All the object processes, camera processes are piped to the rendering process. This rendering process waits until the sound process is completed. Once the sound process is completed, The rendering information is sent to the display list through the frame buffer, and then displayed on screen. The sound output follows the display list. Since this task happens in the background, the sound output is used from the DMA. The sound output event is then dispatched to the hardware. The game then finally checks to see if the course has been cleared. Remember the flags we talked about earlier? This is one of them. And so is the game over flag. If both of those are okay, meaning that both of those are no, we can then return back to the top and it does the same thing again. This is a very well designed and broken down game. It's simple enough to follow along, but it's extremely complicated when you break down each of the fixtures. Now we talked about the happy path, let's talk about if the course has been cleared. So if we've gone through all this process, and the boss has been defeated, meaning the course has been cleared, we now go through the course clear process. The course clear process will not only reinitialize some areas of memory, but also check the registers for a score, to tally on, to keep, goes through a bunch of audio events, and eventually reset you to the menu process. The course selecting screen will then change the displacement of the object on screen representing the R-wing, and then will allow you to make a choice of where to go next. However, the choices are based on in-game data, so all that data in RAM from the scratchpad area is then copied to another location in order to determine where you're going next. If the game over flag is present, well, too bad. Game over process means you're clearing and going back to the main menu. With this introduction to Star Fox 64, I'm excited to dig deeper into this patent and understand how each of these pieces are gone. In the next episode, we're going to talk about how a level is gone through, step by step through a system diagram. We're going to go through each flowchart and understand what can happen at each piece of the level. This high-level overview talked about the happy path of the entire system, and boy am I excited to continue. Thanks everyone for tuning in, and this is James from Zygal Studios, signing off.